Angelina, we are so lucky to have you today, and I am very excited for, sorry, let me just do this for all the musical theater majors. I streamed stream in cues gone by. So everyone, please give a very warm welcome in the Twitch chat, in the Discord, to Angelina Uno and Tonison.
Hello, everyone. I am Angelina Uno and Tonison, and I am very excited to be introducing Apache Kafka with everyone attending today. I work in the Center for Computational Genomics and Data Science at the University of Alabama at Birmingham as a software architect. Our dev team collaborates closely with our scientists and aim to create analysis tools to streamline genomic analysis to make it faster and cheaper, to be more accessible. And so recently, our team needed to evaluate different technologies that we could use as a backbone for our tech stack. This sent us down a rabbit hole of a lot of different options out there. After everything was said and done, I proposed using the use of Apache Kafka. I drafted a code demonstration to practice utilizing Apache Kafka myself and themed it with Animal Crossing, and crafted this talk to help introduce the technology to folks unfamiliar with it. So today I will be covering the what and why of Apache Kafka, use cases that folks have published on their use of it, how to get started using and implementing it, and an example themed with me hosting a dinner party with my island villagers. Today's presentation is a culmination of information from a lot of my favorite articles and videos I have found on the topic. I'll be providing a Git repository with references to all of them so y'all can peruse them at your leisure. All right, onto Apache Kafka. So what is Apache Kafka? Well, let's hear from Isabel. It is an open source distributed streaming platform. What does that even mean? To me, I've boiled it down to a system that allows applications to process events as they occur. Apache Kafka encourages applications to be event-driven. This allows for better insight into the data in the live systems to help provide context. This has been a huge change in thought. In the past, data has been traditionally treated more statically. Let us hop into the core concept of how Apache Kafka works. For a long time now, we've been storing information in databases. Databases encourage us to think about things of the state of things, information such as a user, a personal mecha, or the results of wet lab work. And it has worked for a long time, but it isn't enough anymore. We have accumulated so much data, expensive in time and cost to run these long batch processes necessary to gain insight and context into the data. So we have our databases that store the state of things, and then we have our logs that record events happening in the application. Where events are things that take place in the application, storing these events in a database is unwieldy, right? Logs can mean so many things to different folks. That's stuff that we write to standard out, or content being written to a plain text file. But let's think of logs in Apache Kafka terms. Instead of logs, we use a topic to record groups of records. A topic is an ordered collection of events that is persisted, aka written to a disk and replicated and copied around. Each event in a topic is a thing happening in the business. A user updates information. Our mecha's trajectory is providing updates towards its entrance into the Earth, or the temperature being reported from one of our instruments in a wet lab experiment. Kafka has you think about events first and things and states second. Now we can observe the events as they are being published to the Apache Kafka topic and derive meaning and can act on it. Beforehand, we would be building this one giant program that used this one giant database, and it worked. But the longer they lived, the more difficult it got to change things and difficult to think about. So instead, we can write smaller bits of programs to operate on these events. These new smaller programs are small enough to version and change and evolve on their own without breaking everything else. Then we can have these smaller programs communicate with each other with Kafka topics. A service can consume an event from a Kafka topic and do whatever computation it wants. An example, a program that is responsible for fraud detection. Then they can publish the results to a new message onto a new Kafka topic. The data is durable and permanently recorded. Other programs in the system can read and process. And continue our example with fraud detection. Fraud can be detected on this service running and report it to a new topic. Now, imagine how much this can scale with more and more of these topics and services. We can create a new service that can perform a real-time analysis on the data. We can enrich that data from a database, and then we can send it back to the user now. So let's take apart the words open source distributed streaming platform. Open source, it's Apache Kafka has an Apache license 2.0. The term states that this code can be freely available, can be distributed and modified. You can't remove any existing copyright patent or trademarks or attribution notices. Apache Kafka is maintained by Confluent, and it's a company that was started by the original developers of Apache Kafka. Then we have distributed. You run an Apache Kafka as a series of Apache Kafka broker services that are orchestrated on a cluster that can span multiple data centers. That data within a Kafka broker service is replicated according to a configuration. This way, you can guarantee that if something happens bad on a machine or the service itself is running on, copies of data exist elsewhere already built into the system. Apache Kafka uses Apache Zookeeper to keep track of the state of the brokers within a cluster. And then finally, to our last set of the words in the open source distributed streaming platform. It's where it means really where there is a continuous transition of data in real time. This allows for on-the-fly processing and aggregation of information. So with all of that, you get a highly available streaming service that uses the producer-consumer pattern to interact with Apache Kafka. This allows the publishing of and subscribing of events and /records. And it's the primary transport mechanism that moves the data at scale. There is a high accuracy with this information. You get an immutable record and it's stored exactly as it was received. Apache Kafka allows a playback of existing communication also. So it's not, some message buses allow, once the message is on and it's read, it's gone. And that is not the case with Apache Kafka. The system is also fault tolerant, depending on a configuration. And I'm saying that a lot because it's important how you set it up. Depending on the configuration, if something happens to the machine or the broker running, the cluster will rebalance and data existing elsewhere isn't lost. And the remainder of the cluster is continuing to operate as if nothing happened. So who's using this highly available streaming network framework? Well, Lyft is one. Lyft uses Kafka to combine geolocation data and traffic patterns to report a driver's estimated time of arrival for pickup. Netflix uses Kafka all over its stack, across all of their business units. An example of their use is the Streams API. The recommendations that are provided to users are an analysis done in real time and is not just data calculated from previous days. The New York Times has chosen to use Kafka for its publishing pipeline, which is to serve all of its content from the beginning of the time for New York Times. Cerner is an electronic medical record system that is used in hospitals, and it uses Apache Kafka for its ingestion platform. They take in terabytes of data a day with over 1 billion messages. The platform's responsibility is to make data available to downstream teams to consume. And then another example I was excited to see about was Line. Most folks know Line for it being a chat client or serving webtoons. And they base a lot of their core infrastructure on Kafka with the Kafka Streams API to store and distribute real-time published content. I did want to share this quote with you from Neha Narkade's keynote at the Kafka Summit London 2019. It resonated with me, especially in regards towards the work we tackle in the Center for Computational Genomics and Data Science. Deploying a platform that can provide real-time stream genomic analysis from a biological sample in the NICU during triage could be life-saving. Waiting even a day to sequence, secondary process, and annotate with data a genomic sample, by the time it is done, it is yesterday's data. And we could simply use a message broker in our tech stack and it would work. However, we're thinking beyond the short-term use and to push ourselves to reach much higher. So on that positive note, we're gonna hop on to the use case I also liked. There's this really fun use case, and not just because if you squint, there's this beautiful iridescent squirrel chipmunk logo on the page, but not gonna lie, I had to know what that was immediately, and it is a tool called Apache Flink. So one of the key requirements within Netflix within a financial data set is the strict ordering of events. Kafka helps them achieve this by sending keyed messages. Any event or message sent with the same key will have guaranteed ordering since they are sent on the same partition. However, producers can still mess up the ordering of events. The producer services can have a network timeout trying to reach Apache Kafka or a concurrency bug in the producer code. Out of order messages and can have serious repercussions for a business. For example, the launch date of Stranger Things was originally moved from July to June, but then back to June to July. To circumvent this scenario, producers are encouraged to send only the primary ID of the entity that has changed and not the full payload on a Kafka message. Once the message is produced, the enrichment process, represented by the beautiful squirrel chipmunk thing in the diagram, like AKA Apache Flink, to consume the source service with the ID and the entity to get the most up-to-date state payload, thus providing an elegant way of circumventing the out-of-order issue. They refer to this as a delayed materialization, and it guarantees ordering of data sets. So we kind of talked about an introduction about what Apache Kafka is and how some other folks in the industry are already using it. So this is what the infrastructure or system of an Apache Kafka cluster looks like at the most primitive level. Kafka runs as a cluster on one or more servers that can span multiple data centers. A cluster is a series of Kafka brokers and Zookeeper instances working together. The requirements for setup is each broker must be able to talk to Apache Zookeeper. This is for the leader election. Each broker must be able to talk to every other broker for replication. And how does Apache Kafka even persist this data? The data in the topic partition is split into log segments. For each log segment, there's a file on the disk. One of the segments is the active segment into which messages are currently written. Once the size or time limit of the active segment is reached, this corresponding file is closed and a new one is opened. The great thing about splitting the data of a topic partition into segments, Kafka can purge and compact messages from the non-active segments. Okay, so now we looked at the infrastructure a smidge. Let's hop over and just look at the 4 different APIs that are available for Apache Kafka. Apache Kafka has 4 primary APIs. It has the producer API that is responsible for pushing data onto topics. The data that is pushed onto a Kafka topic is persisted, as we just talked about. It can be saved for minutes, hours, days, or forever. But when I was reading up about how long they were mentioning data was saved, they did say that a week is a long time. So put that into perspective. Then there's the consumer API that allows a service to subscribe to one or more topics to listen and operate on. These subscriptions are in real time, and if configured, it can be set to read from messages previously published. So when you start a consumer, you can say start from the beginning of this topic, from a specific point in this topic, or the last point you were at before the application stopped. Then there's the Streams API. This leverages the consumer and producer API combined together. It's commonly used to consume, analyze, transform, and aggregate data in real time. often results of a stream publishing to a new topic. And then there's the connector API. It is a reusable set of code that reads from a data source and then produces records onto a Kafka topic. So this is really helpful if we're looking into connecting our legacy systems or wanting to enrich our data that's being processed, and it allows us to go ahead and have direct connections with a Mongo database or a Redis service running. So that's a neat thing. I think the connector API is one of the newer APIs that they have listed. Okay, so we talked about what Kafka works and what it is and how people use it. Let's hop into our last step, which is talking about a dinner party on my Animal Crossing island. So I am hosting a dinner party and have invited my villager friends to come. Sprinkle, Apollo, Chloe, and Marshall are all preparing dishes to come, along with my gal, Georgie. Let's create a topic that is titled Food Prep. We will have 2 services running. The Uno and Tonison household service, where I am prepping for the party and doing my business, keeping track and consuming updates from friends and the time till the party starts. Another service is the guest service. And then the other service is the guest service, where we'll be publishing updates on their food prep status and whether they are on their way. We can have a third service that our time till party service is using the streaming API to consume events from the food prep topic. If it's that information it knows, like where the island villagers live and the kind of food they're preparing, and guesstimates how much time is left, and publishes to the time till party topic that I am listening to. So we're all set up. Kafka Brokers and Zookeeper is running mysteriously elsewhere. Our services are up and my friends are starting to publish updates for what they are up to. Okay, so Sprinkle is washing her fruit. Paulo is mixing the batter for a cake. Chloe is washing stuff for her salad, and Marshall is busy pureeing things for soup. And then my girl Georgie has to run to the grocery store to buy stuff for her infused water fruit drink thing. Cool. So we're about 6 hours out and exciting. Everything is on track. Let's keep going and get some more updates. Things are happening. Our friends are making a salad and fruit and stuff. Apollo over here is putting that dessert in the oven, and Georgie is back washing whatever pleasant things she is including in her infused water. And then I realized friends are on their way already because they were just making some salads. So I'm like, gonna turn on that music to help set party time mood. Now, friends are arriving, food is on the table, getting excited. Apollo finished his cake and is en route. Georgie's still flying on over because it takes a while to get there from Salty Island. And Marshall is still chilling out. He has quite a while before he's done with his magical soup. And as you can see, we're updating times with our time till party service. Again, excitement, people are here. Okay, now Apollo and Georgie have arrived. We are down to 30 minutes because all we are waiting for, according to our service, is that Marshall is telling us he's on his way. And I guess he's 30 minutes out. And my daughter has also decided to come out because now there's food and it's showing up because Georgie's here. And now we're all just chilling and vibing. I checked the time till party topic to see we have 30 minutes again. Marshall's coming here. Everyone's excited. Yay. And everyone's here. Party is starting. Cheers to my food prep topic and time till party topic for informing me when folks are coming and how much time is until the party. I hope everyone has picked up something about Apache Kafka today. Get inspired and make your own Animal Crossing themed demo and practice using Apache Kafka. Yay! Thank you for your time and joining us. And if you're interested in the work we do in the center, please reach out on Twitter or in Discord.
Amazing, Angelina. Everybody give a Warm thank you to Angelina, Una, and Tonison in the Twitch chat, in the Discord. And don't forget about the speaker Q&A. Angelina, are you up for a Q?
I think so. Let's do it. Let's do this.
How do you get lab instruments to send data to Kafka? Do they speak native Kafka, or do they have to send data to a hub? How does that work?
What I would imagine doing is probably they'd be running a service that communicates, that has some sort of hardware that's set up on the native machine, is communicating with it. And then that service that they've created that's reading the temperature data would then also be implementing the Kafka API to then interact and report those wet lab instrumentation stuff. What could be done also is to implement a custom connecting API that maybe might also do that also as a transition and make it more fluent, depending on what technology it is. But you could probably just hook up a Raspberry Pi. I think one of the labs I previously worked in, they hooked up a Raspberry Pi to read the temperature of the room and then that reported temperatures out. And in this use case, we could then have that same program. There's a Python framework, Python API that you can use with Kafka. They could have just plopped that right in there into their program and operate and do things on it and report out.
That makes sense to me, which is really a credit to your talk, because this is the most I have ever understood Kafka, with the exception of my English degree in Franz. So this was really great, and you should absolutely go through the chat because people loved it and they love you. So everybody, one more time, say thank you to Angelina. Warm chats. Send over all the emojis. Just show the love.